Hi, this is Mr. Manley. Today we're going to talk about how to solve an equation that is in a particular form. It's actually the quadratic form, and if we cannot factor it, say we're looking at this and we're trying to solve it by factoring it, and we find that we can't, then what do we do? Now, in this one particular case with a polynomial that is quadratic, that is, we have a polynomial with x squared, we have a way of solving it using the quadratic formula. So this is the quadratic formula on the right side here. And the idea is that if the equation is in the form y, or we could say y equals, but let's just say ax squared, ax squared plus bx plus c equals 0, the solution to this is going to be here, negative b plus or minus b squared minus 4ac over 2a. So when I can't factor this equation on the left here, if I can match up, if it is in this form, and I can match up this a with this, and then the b from the ax squared minus bx plus c with this, and that's going to be b, and the c matches up with this, and that's going to be c. Then I can use this formula in order to solve it. So the way that we do this is simply by plugging in. So I'm going to plug in the b, which in this case is 4. And it's going to be, since it's a negative, it's going to be the opposite of b. So I'm going to go negative 4, and then plus or minus, and we'll deal with this plus or minus later and what that means. And then we get the radical, b squared, so the 4 is going to be squared, minus 4, and that 4 is this 4 is this 4. If you look over to the right, it's that 4 from the quadratic formula. And then we have a, so the a that we're looking for, this a is here, whatever number that is. And in this case, if you look to the left, it's that 5. So we're going to plug in a 5 for a, and then the c here in the formula means this c, which in our equation is minus 2. And we'll plug that in. And then all of that is over 2a. And we've already said a is 5. And we simplify this. Now this is what x equals. Remember, we're trying to solve for x. We're trying to figure out what value of x will make this come out to 0. So we're trying to figure out x equals what. We tried to figure it out by factoring. We weren't able to. And the quadratic formula is giving it to us only because we have a quadratic. This is the only case in which this quadratic formula can be used, if we have a quadratic. So simplifying the expression, x is equal to plus or minus, and that'll be 16 plus 40. You can take a look at that. I've got a minus and a minus, which is going to end up with a plus. And then I've got 4 times 5 times 2, which is 40. And all of that is over 10. Now, I think you should pause at this point and see if you can simplify that. And then after pausing, we'll show you what it is. Okay, so after pausing, I hope you did, and simplifying, this is what you're going to get. If you're not getting this, then you need to do some work with radicals and simplifying rational expressions. And that is our solution. Now remember that there's this plus minus here, so there are actually 2 solutions. And we just use the plus minus to write in a more condensed form, so we don't write out 2 expressions. But let's take a look at what those 2 expressions look like. All right, so this is what the the plus minus, how the plus minus works. So if you look, we had the plus minus there, and what that means is that we can have the expression negative 2 plus rad 14 or negative 2 minus rad 14. And what that means is that if I plug this in, so if I say take this, either one, but say I take this one, if I plug it in for x, here, this is going to evaluate to 0. And that is the number that will do it. If you want something more, if you want something more concrete that you feel like is a number that you're more familiar with, we could do a decimal approximation for this. So I could take this and say that this is approximately negative 1.148. But that's an approximation. I mean, it gives you an idea about what the value is, but the exact number that will work is negative 2 minus rad 14 over 5. And this negative 1.148 is just an approximation. And it's not something that we would do. All right, we don't need to do that. But I just want to point out that it is a number. It's some number that if I plug it in for x squared and x, it's going to come out to 0. And this is the number exactly, and this number as well. Okay? So let's look at just one more case here. All right, so here's another quadratic. Now if I wanted to solve this, what I would do is I would take negative 8, and I'd look and I'd say, okay, that's because I've got 4 times negative 2. And I'd say, all right, that means that I want to see, are there any factors of 8 where the difference between the factors comes out to negative 5? So this is a method that I teach for factoring that I recommend in some cases. And what that shows me now is there's no 2 factors of 8 that will give me a difference of 5. So I cannot factor this using FOIL. So no matter what I do, if I go 4m and I go m, or if I go 2m and I go 2m, I am not going to be able to factor this. So hopefully what that means to you now is that you will use the quadratic formula. So let's pull the quadratic formula back up. And we will solve, in this case, for m. So we'll say m equals, and then using the quadratic formula, negative b. So that's the opposite of the middle term. So it's the opposite of negative 5. So it's going to be positive 5 plus or minus the square root of b squared. I'll just go ahead and square the 5. Minus 4ac over 2a. So we can just go ahead and say 2a is 8, right? And then simplifying this, get 5 plus or minus. This is 25 minus 32 over 8. Let me see if I did that. Let's check if we did that correctly. So there's b squared, 25, and then 4ac. That's 4 times 4 times negative 2. Okay, I think I copied down the wrong problem. Just give me a moment here. Yes, I miscopied this, so I'm just going to make one little change here. I'm going to call this a plus 2. So make that change in your notes. And then my work will be correct. And then the next step to simplify this is going to look like this. And hopefully you know what that means. At this point, I've got a radical negative 7. So my 2 solutions are, and I'm going to jump in and split up the plus minus. So I got plus 5 rad 7i over 8. So do you understand that? That if you take this rad negative 7, that's rad 7i. So we've got an imaginary solution. And then here, and then I could also say 5 minus rad 7 I over 8. And this, you don't have to do this. So this part, you don't have to do this. We're just showing that there are two solutions, and you don't have to split them up like that. There are two solutions, and they are imaginary. And pointing out that we can get imaginary solutions. Now, what that would mean to us is just consider, do you understand why we would be setting a polynomial equal to 0 and solving it? Maybe yes, maybe no. It might be part of a word problem. It might be a reason that we're solving it. And then when we solve it, we find out the solutions are imaginary. So in the context of the word problem, that would be, well, there's no solution. It could also have to do with graphing. If I let the expression be equal to 0, it might be that I'm looking for the x-intercepts. That's what it means when I set an expression equal to 0. I'm looking for the x-intercepts. And then if I come out with imaginary solutions, well, that means there are no x-intercepts. Well, I'm sure you can imagine that that's a possibility when we're looking at a graph, that there are no x-intercepts. So this is giving us the idea that we can get imaginary solutions and having some understanding of what those imaginary solutions mean. Okay, so good luck with solving quadratic formulas, and if you have any questions, ask your teacher.